Hello, everyone. Thank you for joining us on this fireside chat of CodeBeam V. Some of you already have their cameras on. Thank you very much for doing so. Others, please consider doing it. It's nice to be looking at faces. It's nice to have some feeling of the actual crowd that is out there looking at us deep into our souls. I'm Stavros Aronis. I have not written my own programming language, so I am mostly a host in this session, keeping track of time and the questions that come via digital channels. And I have with me Louis Pilfold and Leandro Ostera, who have written their own programming languages and therefore are the stars of the Fireside Chat. We will have the unmuting option actually available for you. So at any point you can unmute yourselves and join the discussion and ask questions. You can also post questions in the Q&A section of Whova, and I promise you that I will read them if you want me to do that. And with that, I think that we can start. And why won't we hear a bit about our stars? Louis, do you want to start? Tell us about yourself.
Sure thing. Hello, everybody. My name is Louis Pilfold. I'm jack of all trades, software developer, and real lover of Erlang. But I'm here because I'm also the creator and designer of the Gleam programming language, which is a language that emphasizes scalability and type safety, and using types as an assistant tool in order to help you write code more productively. So it's very much inspired by ML languages. And I've worked in lots of places, but actually I'm very lucky to say that I work full time on Gleam at the moment, thanks to the help of my sponsors and such. So yeah, that's why I'm here. It's all very exciting.
Amazing. Leandro?
Hi, everyone. I see a couple of familiar faces there. Roberto, Niels, Håkan. How's it going? My name is Leandro Ostera. I am a software developer as well. I've been doing this for a bit over 12 years now. So I've done a bit of front end, a bit of back end, some infrastructure, and whatnot. I've always done a lot of work in dynamic languages, and then at some point I just met OCaml and just ridiculously fell in love with the way of thinking. Yeah, I kind of have to at some point acknowledge my limitations as a human, right? I can only do so much in my own head, and it feels like type system is a good tool, right, to help me write better software. So once that clicked on me, I realized I need this to be able to do better than before. It kind of crippled me in a way, right? Because now I can't really do dynamic programming without the types already being there invisibly. Yeah, and I started working on Caramel, which is, I'm not designing it from scratch. It's kind of like OCaml as you take it and trying to make that run on the Erlang VM and sort of chopping the things that don't work very well, don't make a lot of sense on the runtime that we have. What else? I sadly don't work with Caramel full time yet, but I'm going to be starting a company on June now first, and I'll be doing a lot of development with Caramel as well. So that's going to be exciting. Yeah, I think that's about it. We can move on.
Very much covered the opening I had in mind. And you have also given a brief overview of what those languages are about. Starting a bit on the light side of things. So what's in the name of the languages, which is a burning question for a lot of people.
Okay, I'll go for, well, it was a tremendously profound experience coming up with the name. I picked up a dictionary and I said I needed a name that was easy to spell and quite short, and I started at A and I just kept reading. So A, B, C, D. I eventually got to G and I went, Gleam. Oh, it rhymes with beam. It's quite easy to spell. I looked at an Urban Dictionary and went, it doesn't mean any sordid act that, will cause people to snigger. So yeah, I quite like it. It's very happy. And it's sort of like evokes ideas of
it's pretty cheerful.
Shining in the darkness. I quite like it.
Yeah. I think that it has that vibe. It's like cheer, right? Like
yes. Yes, I'm trying to make Gleam a very, we talk a lot about the technical side of languages and tools, but actually, the way it interacts with people is so important with tooling, because, if you're working with something all day, it's either going to ruin your day or it's going to make your day. And I want Gleam to be a happy tool. I want people to go, oh, I get to work with Gleam. That's excellent. My day is slightly better because of it.
Like, if at some point you have to acknowledge that building software is fundamentally a social activity, right?
Yes.
Like, we're interacting with other people. So, naming a software, artifact has to be taken into consideration in the scope of the people you're working with. For me, Caramel wasn't as much of a like, I'm going to find a word that's kind of good for it. I was honestly thinking most Erlang projects either have names like Pullboy or Hunk, as we were talking about, or they end with Earl. There's something Earl, right? Like pure Earl, for example. And I wanted to do something like Camel Earl, but it doesn't roll off the tongue very nicely. And about the time it was my last birthday, so 28th September last year, I was feeling a little homesick. And if you spell out Caramel, right? You can almost have all the letters to write caramel. And I was thinking of dulce de leche, which is something we eat a lot in Argentina. So I thought, well, caramel sounds like a nice thing. So I just named it that and went on. And it turned out to be like, I think it's kind of a nice sweet brand, like something like sticky that you enjoy eating. Not too much of, hopefully.
As much as you want of, actually. It's supposed to be safe for you.
Yeah, exactly. Safety first.
Let's see. And this has how long have you been working on this, Leandro? We already discussed, it's about a year now that this has been going on, or?
Well, I would say less. So October, maybe, let me do the math. Let's say 7-8 months. We're month 5 and we were at month 9. So 9, 10, 11, 12. Yeah, 8 months or so.
And Gleam has been around a little bit longer.
It's been a little bit longer. So there's kind of like 2 beginnings for Gleam. The first one is when started writing the compiler properly, and things started to happen. It started to become an actual thing that you could use, and that really kicked off in January of 2018. So that was 3.5 years, something like that. But there was actually like a secret, hidden actual beginning that you can see if you look at the repo, because Gleam actually originated from a conference talk called what was it called? It was called Build Your Own Elixir or something, and it was about making a compiler on the Beam. So I did that thing of signing up for a conference talk and saying, yes, I've got this compiler, and then I got accepted, so I had to make a compiler. Which there was the first prototype of Beam, and I did the talk, and it went very well. And then afterwards, there was a big lull. And during that time, there was a lot of just thinking, what actually would my ideal Beam language look like? And there must have been like 1.5 years, maybe 2 years of like no code, not a single line of code, but just lots of like standing around, like sitting on a park bench, being, what should it be like? What is my ideal Erlang? So I think that big conceptual bit of sort of stewing ideas is super impactful on Gleam, actually. It turns out lots of planning can actually make a big difference.
And the thinking is the hardest part in everything that one can get to do. And it would be great if we were able to do a lot more thinking and a lot less coding, while still proving that you're working. I
don't know. I wouldn't want to do only thinking. I like to do things.
You don't have to write as many tests though, so that's quite nice.
All right. Let's dive now a bit deeper and pick some question from Q&A. Favorite problem, insight, or surprise about using stronger type systems with the Beam? Anything relatable?
So I've been using Erlang for about 6 or 7 years, I think, but prior to that, I was writing mostly a mix of Ruby and Haskell. So I was always very into type systems, and I'd always hear people say it's not possible to type Erlang, it's not possible to type Beam languages, and I just sort of took that as a given. And then when I started this project, I think the thing that struck me was that that's kind of a misleading statement. like it's actually surprisingly easy to make a useful pragmatic typed language on the Beam. The thing that's challenging is actually applying types to OTP while not changing the interfaces that are used. So you can make a typed language on the Beam quite easily. Like all of the ML family languages, for example, OCaml, fit very well with Erlang. You know, once you strip away the type system, they're very similar languages that manipulate values in very similar ways. And then if you look at what OTP does, the idea of sending messages to, sending message between processes and having supervision and stuff like that, these are things that actually you can represent with types like relatively easily, as you can, well, not relatively easily, but you can do it. It is a thing you can succeed, and you can look into places like Pony and Akka and Cloud Haskell in order to see similar things that work that way. The thing that's really hard is taking Gen Server, like that one particular interface with, cast and call and info, and making that type safe, because this is an interface that is not in any way designed around types. So, it comes down to how much of OTP are you willing to shed in order to get your types, I think.
Drill down that point and say that it's not really the interface, but rather the dispatch mechanism that Gen uses under the hood that makes it, I want to say, intractable, or let's say just really hard to type. Like I haven't been able to type that little bit, just because you have to just take the function name, right, the symbol as a value, and what are you going to do? Carry the type with that value? You need an entirely new universe of type values to pass around. But if you stick at the edge of that, just like in most languages, like even Haskell, when you write an FFI, right, you point to some other code that may be completely unsafe and just destroy all of your assumptions. If you do the same thing with OTP and you say, this is part of the runtime, right, it's just an FFI something else, then you can type the interface to a Gen server, for example, quite nicely. Like you just get these nice type functions. Under the hood, there's something weird happening. We don't really touch it. We don't speak of it.
Yeah, so the question I think then becomes like, what is your interface that you're typing? Is it the functional facade that we put in front of like the actual nuts and bolts of these Gen servers, or do you actually want to be able to type message passing? And for about 2 years, the only thing we did was we typed the facade. But with I can't remember how long it's been out. Maybe it's half a year ago, maybe it's a year ago, we released Gleam OTP, which actually is a full re-implementation of OTP. It has a core of about 400 lines of Erlang, which basically implements send and receive and selective receive, and that's it. And then we implement not the same interface as Gen Server, but something that's equivalent, that is equally powerful, that is capable of being typed and has full compatibility. So you can put it in an Erlang supervision tree, or you can put Erlang supervision trees inside a Gleam one. Like that works. And so it is possible. The only thing we have to do is just shed some of the decisions that were made by the OTP team, who are optimizing for a different thing. And what they did made a lot of sense for a dynamic language, but it just doesn't fit with our constraint set.
Yeah. I think that's a very good point. Like, if you ask me what are the two, or what's an interesting problem that I found when trying to build a type language on top of the Beam, is that people that say that it's impossible to type Erlang consider hot code reloading part of the language, not part of the runtime. And when you strip out hot code reloading, you essentially have a static set of code that you can analyze once and then load once, right? So then that's an entire set of problems you no longer have. Now, I'm not saying that we shouldn't do hot code reloading, or that we should. There's use cases for it, right? If you do have the use case, then if you want to type it, you will end up with a very strange, eventually consistent type system, where you have to carry around sort of the information of whether something is type checked as you reload the code across a cluster, for example. And that sounds really interesting, but I don't know if it's going to be pragmatic at all. So I'm just saying, well, Caramel is not going to support this. If you do hot code reloading, and I assume that's the same with Gleam, right? If you do hot code reloading, then you're on your own. It's like,
yes, that's the Gleam strategy. The Gleam strategy is, if you want to do hot code reloading, you get the same guarantees that you get of Erlang. So you don't lose, but you don't gain anything either.
Exactly. Yeah, at some point, I think that we started with a problem and we found things that were kind of harder to do, and say well, that's not going to be part of the problem anymore, reducing the problem until we can build something that's usable, right?
But I think there is, well, this is an idea of Jose Valim's, I believe, actually. We were chatting sometime, and he said, "Oh, what about this?" And it sort of blew my mind, really. If you know the types to the interface of your entire program and all the internal mechanisms, you could store that in some serializable fashion. And then if you stored that as part of the release, when you do a rel up, you could say, hey, here's my type information, what's your type information? And then you unify those two things, and you can work out if they are compatible, or you can work out if there's an appropriate upgrade mechanism that is capable of going between those two types. So it would need to be structural typing at that point, which slightly causes a problem for both Caramel and Gleam, because they use some nominal typing as well. But like that is a really interesting, that could be a really interesting, powerful project, which, I think famously people say that, testing your releases actually takes more time than testing the actual code that it contains. If you had this type upgrade system, we could save Ericsson a lot of money, or like whoever it is that uses these things an awful lot.
My guess is Klarna does some of that.
Klarna, yes.
Yeah, but it's also interesting to think that if let's say you encode all this information, right, in some additional chunks on the Beam file, right? You probably want to version the type system itself, so that bugs in the type system or fixes, right, are detectable when you look at the type information in there. And then you will want to either encode the type system somehow in the release, so you can do the verification and sort of do the same checking that the runtime does when it loads a Beam file. You say, well, what's the max structure number you have? Is this one? Yeah, I can run your Beam code. Otherwise, no, this was compiled with a newer Beam, Erlang compiler, so I can't really run this. And then you would decide. But that means that if you have several nodes, right, when you start doing this hot code reload and you propagate the new bytecode, you will have some nodes that will not type check, potentially.
Yes.
So you will have a system that is like in an inconsistent type state.
Well, it's kind of nice that you. It's kind of nice that you get told that you're in an inconsistent state, rather than the current thing of you just do an upgrade and then you're in an inconsistent state, and then you just find out later when things start to go bang.
Or next question.
Right, and you are briefly touching on more questions here that are coming in. So this discussion, for example, how you do dynamic code upgrades in a statically strongly typed language on the Beam, has also come in explicitly, how you can do this kind of thing. But I guess this right now is in the realm of design and thinking for both Gleam and Caramel.
I think the strategy for both languages is that you just use the same mechanisms that you do with Erlang, and you will get the same level of success and supports. But we have identified some ways in which you could build a system to make this better, and you could use the Caramel compiler or the Gleam compiler as the basis of this.
Exactly, yes.
But we're not doing it because we've got a language to make. So
very wise, very nice way of saying we don't.
Yeah, I think I just said pull requests accepted.
Pull requests accepted. Yes. I mean, OTP is using the same kind of prompt sometimes, the OTP team itself. So it's I guess it's accepted parlance. On the similar note, I am intentionally, by the way, ignoring some questions to get to later. So, please keep voting in the chat, and I will get to them. There's a question about gradual typing. Gradual optional type system with no runtime checks be an incremental way to overcome some of the obstacles found when trying to fully type an Erlang program, a true Erlang program.
So I got.
Sorry, okay. We have a little bit of the delay, so we're going to be apologizing to each other for a while. Yeah, I'll just go. I guess you have two ways of dealing with this, right? Either you choose to grab the core of your program and make sure it's safe, right? Or you and rewrite that so that it's safe, and then interface that with the unsafe parts, or try to sort of make sure gradually that the entire system gets safer. Which I think is the approach that RLT, recently released. Is trying to approach. You just grab a bunch of Erlang code and you transpile that to dynamically typed RLT code, and then you can start tightening down the type constraints here and there. I see Richard Carson's nodding his head, so that must be right. Yes. In particular, I am more fond of grab the core of the application and just write that in a way that you can be guaranteed would be the safest. and then interfaced through that, which is sort of the same way that I've been exposing libraries from like C or Rust into OCaml, from C into OCaml, or from C through Rust into Elixir, right? There's so many gaps in here. Jesus.
So I think excuse me. I think gradual typing is one of the most interesting, exciting developments in recent years. I think it's wonderful how it's taken things that seem like they're impossible. Like, how do we put types on JavaScript, while still being integrated with the whole JavaScript ecosystem? And then TypeScript and Flow have both done fantastic jobs with that. And I think that's absolutely revolutionary stuff. But I think it's important when you look at these things to realize that you get a different they are suited to different constraint sets. I believe they have different advantages and they have different disadvantages. So I mean gradual typing and the sort of stricter typing that you would find in ML style languages. So I'm largely of the belief, and I'm sure people would disagree with me here, that if you're starting a code base from scratch, it is strictly worse to use a gradual typer, because I think the advantage of a gradual typer is that you can apply it incrementally to an existing code base. So if you for example have 1 million lines of Erlang and you want to start using types, something that is optimized for being able to integrate over time is going to be really beneficial to you. But if you have no lines of Erlang and you want to get the full use of types straight away, having something that requires you to put less programmer effort in, but still offers you more safety or more assistance, I think that would be more beneficial. So you can.
Let's touch on that for a second, because you're saying that there's a trade-off that we're making, right? We pay some cost, developer time, developer knowledge accrual, right, for some safety in the program. But that's the assumption that we're making. And I'm not talking about RLT because I haven't had a chance to use it just yet, right? But I've had a chance to work with Flow and TypeScript.
Yes.
And a lot of what I've perceived was perceived safety. Yes. But I didn't get much safety, right? So I got some out to completion here and there. I had to do a crap load of annotations in TypeScript, right? But I didn't actually get the safety that I thought I was getting. Like when you do something like Rescript, for example, which is an OCaml-based language.
So I think this is the important thing. So the rule of gradual type systems is that they can be as safe as I wish I had a word for it. I'm just going to call them strict type systems, but I'm not sure if that's correct. So just if that's wrong, please shout at me. But an ML style type system. So if you have full and accurate annotations on a gradually typed program, you have the same level of safety as if you have an ML program with no annotations. Annotations make no difference to the amount of safety you get with an ML type system. So this relies on I would describe it as programmer discipline and programmer knowledge. You need to know how to use your type system well enough in order to wield it correctly, in order to get the amount of help from the compiler that you want. And I think that is that's great, because you can then apply it incrementally in ways that the compiler couldn't just automatically do. For example, if you have a code base that can't be typed yet because it was written in regular Erlang or regular JavaScript, whatever it is, but it's a much more difficult experience than if you were starting from scratch and you just had this, the nice warm place of Caramel or Haskell or Gleam or something, which will tell you immediately when you get something wrong. It will help you rather than it depending on you.
Right. It's like on the one side, if you go for one of these like complete or total type systems where everything has to be properly typed, right, then you have the compiler sort of holding your hand, walking you through building your program. If you go for something like a gradual type system like TypeScript or perhaps RLT, but I haven't tried it, right, then you kind of have to learn how the type system works so that you can use it. So you have to hold your own hand as you go along. Now, I think another point that we haven't touched is that the scope or how big a gradual type system will be in comparison to a non-gradual or total one, from what I've seen, seems a little bigger. Yes. Like TypeScript is a massive type system, right? And if you compare that to Flow is just a little smaller. If you go to like Reason or Rescript or grain or other like non-gradually typed languages, right, the scope will be a lot smaller. So I haven't yet walked myself through the entire RLT sort of type system, right? But if I did, I wouldn't be surprised if it was a lot larger than the subset of the OCaml type system I'm using or the type system that Gleam has, right?
Yes.
Which means the amount of stuff that I have to learn to get up and running quickly in a safe way may actually be less, even if I have to put a little more time to get the actual safety of a total system. Like I'm not sure we're gonna come out of this discussion saying like, oh, this is a better idea than the other one, but it's interesting to see all the variables at play, the dynamics they have, right?
Yes, and I think that's important. Like there are situations in which one is strictly better than the other, but like there isn't something that wins overall. It really does come down to your
it's just straight up,
what you're trying to do. And people ask me, why isn't Gleam a gradual typing system for Elixir or Erlang? And I would say because so I've been doing this for 3.5 years quite heavily, and we've now got to a point where we have a language that works, people can use it and have in production, and we're building tooling. That's wonderful. I think if we were doing a gradual system for one of those languages, we would still be building the type system. I think it's just a much larger job. And it becomes something that is really quite difficult for largely one person, that grows into a community project. That's going to be very difficult.
Speaking of statically typed languages on the Beam in production, congratulations on Send Memo, which is written in Gleam, right?
Oh yes, it is. Yes. Very exciting. Peter's a real trailblazer.
I have two questions that can be, I want to combine kind of as one. So there is a question, perhaps mostly for Leandro. Outside of processes, which other parts of Erlang have you found that are hard to type, like improper lists, guards, multiple clauses, pattern matching? What has shown up to be hard to type? And combined with this, there was one more. Where is it?
I can start answering that one.
Yeah, perhaps you can do that.
So 3 things I found that are hard, or that I'm just saying, no, Caramel's not going to type these things. Hot code reloading, right? Dynamic dispatch, and returned union types. So if you want to return something from Erlang into Caramel, then you will have to make sure that the union, right, is tagged. So if it's going to be a tuple, it has to have an atom on the left. And if you want to interface with a library that already exists and returns a tuple of 2 values that can change, can be different types, then you'll have to write a little bit of FFI between, some glue code in the middle, so that you can grab that value and just turn it into something that we can type and work with on the other side. Yeah, that would be the.
Gleam's almost exactly the same. So good. I'm glad we're coming to the same conclusions.
Yeah.
But while you're discussing earlier, I had this thought, and it comes back here as in the questions as well. So at some point you will probably, you're not in the universe where you, unfortunately, I mean, you have your languages, you have everything there, but at some point you will have to interface with Erlang, for example. This is a board there. And one way to pose this is, how much type annotations do you think are acceptable? How much would you require, or how are you solving that how it's solving that engineering problem, that trade-off? So how can you get all of the Beam ecosystem to play well with you in a nice way? What are your thoughts there?
I'll have a go. So I'm going to say something I think people probably find surprising. When I'm writing Erlang Elixir, I don't use any type annotations or type checking at all. I find the tools that exist inside the Erlang in Elixir ecosystem don't offer me the developer experience I want. I want something that's like, I'm spoiled by Haskell and such. I want something that's really fast and can give me very immediate and detailed feedback. And because I couldn't get that with Dialyzer, I just didn't find it very useful. So I opted not to use it. I didn't feel like I was getting the time back. But I know that people do use it, and people find it tremendously beneficial, I'm told. And as such, when we have this wealth of type information inside a compiled Gleam program, so when we render Erlang from Gleam, we output guaranteed to be correct type specs. So if you run dialyzer, it can read all the annotations in the generated Erlang code from Gleam, and then it can unify that with your Erlang code. So that's one way in which we help. One of the core principles of the design of Gleam is that interop interop is really important. There's no point saying we are in the Beam ecosystem if we don't play ball with the other people in the Beam ecosystem. And I don't just mean, yes, you can use Cowboy from Gleam, and I don't just mean we can use Erlang. I really want Erlang people to be able to use Gleam stuff, and I want them to be able to use it transparently. And it's, this has resulted in things like people ask me why Gleam doesn't have, some common features in ML languages like auto currying, or all these automatic partial application things. And one of the answers to that is just that it actually becomes quite difficult to understand how you're supposed to call these functions from Erlang. Like, do you call it once per argument, or does it expand in some way so you can call them all at the same time? What if I want to put in half of the arguments? How do these things work? It's like, let's try and keep as close as possible to the conventions of the wider Erlang ecosystem. So you shouldn't ever have to worry about the fact that this is written in a different language. I don't know if we've got this. I like to think we have, but I'm not sure. I want it to be that you could be using a Gleam library and just not know it. Like, it should feel as Erlang-y as possible. So yeah, interop is very important, I think.
Yeah, I 100% agree with those points. In fact, from Caramel side, it's almost the same. Like, I can't yet guarantee that all the generated Erlang code will pass the type specs of the dialyzer. I have not tested that, but it should be readable and it should be somewhat instructive. And we do auto uncurrying, so you can curry functions in Caramel, but they will be uncurried for you. The one thing I will note is that I think we've spoken of Gleam and like static type language to Beam languages interop, but we haven't touched the other way around, right? Like, we want to use Cowboy. What would we do to do that, right?
Yes.
And I think we might have touched a little bit on that when we were talking about typing OTP, because it's kind of a similar problem, right? It's someone else's code that you want to use within this language. Sorry. In Caramel, we have this concept of an external, which is really just an FFI. It's just a way of saying there will be this symbol whenever you run this program sometime later, and it should have this type. So if you want to bind to like UID library, for example, you don't need to write the entire specification of the library. You can just make a module, write UID.ml, and you can say, well, there's this one function I need, external. So in one line, you can get the FFI that you want. Which is very handy if you want to just like hack on something, grab those libraries, write the FFIs, use them, see what happens.
Pay as you go.
Exactly, pay as you go, yeah. And I imagine that Gleam would have a similar mechanism as well, but what do you want to talk about it, Louis?
Yes, it's pretty much the same thing. We sort of say, that people ask, oh, why can't you just type check the Erlang? I was like, no, we've established that's the hard thing. Like that's a larger project than making the language. So yes, we use the same, like here's a clear FFI barrier. You tell us what it's going to be and we're going to trust you. And if it doesn't work, well, then you're going to have problems at runtime. But like that's just what happens when you use dynamic code. And that, the nice thing about this is that, when you're using this, and this goes for Gleam or Caramel or any of these other languages, when you have your system all typed and then you have a type error at runtime, as it were, you can identify exactly where it happened because it's going to be at the FFI barrier or any place that you say like unsafe coerce. Like those are the only places it can happen. So, people say, oh, it's, it's terrible. Never violate the type system. It's like, well, it's not ideal, but at least you know exactly where the problem is going to happen. So it becomes easier to debug.
And I will take this as a sideways answer to the question. So what if you want to go back to Gen server and all these hairy stuff, can you just type the interface? Yes, you can. Maybe that's the same way to do it. And just forget about everything else.
I guess there's the interesting academic problem, and then there's the interesting industry problem. And right now we're like, we need to build stuff. We'll figure out
engineering and not
later.
Everything can be.
I think the recommended strategy for Gleam is that if there's a pre-existing library that offers a functional interface, maybe a pool boy or cowboy or something. Don't try and represent their supervision tree using a typed OTP system. Just use the FFI barrier with their functional interface. But if you're trying to make programs that use processes and supervisors, in which case you'll probably want to be using Gleam's, down to the ground type safe abstractions, because then you actually do care what's on the inside.
Exactly.
One more question is about the macros. Are there macros? Are there plans of adding macros? I'm not familiar with the languages themselves, so I don't know what this entails and how is it. How hard
we're
is it?
talking about Elixir style macros and not Erlang style macros. I see an okay over there. Yes. So I guess yes and no, at least for Caramel. We can do compile time macros that are type safe. You have to do expansions on the AST as well. But right now, the OCaml ecosystem, I'm essentially reusing like 90% of the compiler there, right? It has a wonky way of working with this because you need to compile your macro to a binary that then you run your sources through, and that source is actually what you compile with a Caramel compiler. So that's pretty uncomfortable to do right now. So it will take some time, but maybe it is something that I would like to include. I just don't know how to do it nice yet.
And as for Gleam, maybe it's hard to say. So I think it's very tempting when building. This goes for languages, but this goes for any product really. It's very tempting to build a core and then get excited by a feature and just sort of like add things, but you don't necessarily know what impact that's going to have on the product, on the ecosystem that uses it. So you've got to be very careful. It's very easy to add features. It's harder to add them well, but it's extremely hard to remove them. And so Gleam has, it has a core language which is very conservative. And actually, if you look at a lot of the previous release notes, we've just cut off a bunch of features over the past 2 years. And we've got something that looks very similar to OCaml in many ways, or Elm, or one of these languages. And we know that that is enough for people to go out and make practical, useful programs with. People can go out and have fun, and people can go out and build businesses with it. People can do whatever it is they want to do with programming language. And that's great. And now we can start focus on things that people maybe are less excited about, but they do need, like editor integrations and better documentation and tutorials and all these sorts of things. And I think that will actually pay much more dividends than a macro system. But I do want a macro system.
Hands down, with all that.
Yeah, so we have to do all of this stuff first. Like we need to implement language server protocol. We have to work out what is the perfect onboarding experience for Gleam. Learning Go's wonderfully easy. You don't even have to install it on your computer. I want that for Gleam. But then once we've done all these things, then we can then work out like, okay, what language extensions do we want to add? And at that point, the trade-off, it's going to be a lot of design, and the trade-off is going to be what does this bring, what does this enable us to do? But at the same time, it can't compromise on the idea of Gleam being easy to learn and easy to pick up. If we had type classes tomorrow with higher counted types, awesome, I'd love it. But like most people would probably suddenly find the language a lot more challenging, and that would be a real problem.
All right, we are down to our last minute. There is one big question still outstanding, but I will ask it outside of the time. So in the Toucan, and this is all the opinions and impressions about RLT that just came out.
Could we ask a question to the audience just to get an idea?
Maybe, I don't know.
Yeah, really unplanned. Yeah, I just want to know how many of you work right now with statically typed languages and with a language on the beam at the same time. If you want to raise your hands.
There are 3 visible hands, but 2 of them are from Phil.
That's me as well.
And
Lars Wickman over here as well. Okay, so 4 people. All right, like 10% of the audience.
But
that's cool. We've probably got most of the typed beam ecosystem in the school then.
All right. But with that, I want to thank you both for joining us here. And everybody, please go and find Louis and Leandro outside in Toucan and talk more with them about statically typed languages and all of that. And thank you very much. Continue enjoying the conference, everyone.